Alright, here we are in part 2 of our interactive objects tutorial for our first-person narrative game. Now, where we left off, we have the player able to detect what they're looking at. You can see it prints to the console in the bottom left. You should see it says it's looking at the cube, it's looking at the plane. Next step, we want the player to be able to click on something that's actually interactive, and then it'll do something special. And in order to get that going, we need to not just add functionality for the player, but we also have to sort of define what an interactive object is. And when we go to set that up, I mean, this is something we want to be very reusable. We want to create a whole framework for interacting with stuff in our game. And there's a handful of ways there's probably numerous ways you could set that up, but I want to talk about a couple ideas. So first of all, inheritance. This is like an object-oriented programming staple, and if you're not super familiar with it, I recommend you go to the notes and find the part about inheritance. I like these Unity tutorials. They're short, and I think having the context of Unity is an easier way to learn it than just through console apps. So if you're feeling shaky on what inheritance is, I encourage you to pause this video, go watch this one, and probably also watch this one too. Watch all three of these: inheritance, polymorphism, and interfaces, and then come back here and we'll pick it off from there. Anyway, quick refresher, because I want to describe a little bit more about the difference between inheritance and interfaces, so we better explain a little bit about what inheritance is. You have a parent class. It can have a variety of properties and methods inside, and then you can make children classes that or derived classes that inherit from this parent class. So they would inherit all of this stuff. So you can think about it, we can make a generic enemy class and then make sub child classes from it that will reuse all this common functionality. And that just saves us from having to implement the same features more than once. So you never want, if you find yourself copying and pasting code, it's always a red flag, because that means let's say you wind up fixing a bug or adding something better to that code that you copied and pasted, you got to remember to go copy or fix it, make the same fixes to all the spots you copied and pasted. But if you set something up like this, if you change the way die or taunt works, it will propagate down into all of the child classes automatically, and just makes your code base easier to extend and debug. Now, so yeah, inheritance is providing hierarchical organization. It's saving you from redefining stuff. Let's talk about interfaces. So interfaces, which I think is kind of like a confusing word maybe, but they help with organization as well, and they also help with clarity. What they do is they essentially provide a public promise of what a class can do. So if you think about an interface in C#, the naming convention is that your interface is going to start with I. So you would make an interface called IDamageable, and every single class that uses IDamageable has to provide support for HP, take damage, and die. So one big difference between an interface and inheritance is that these functions are only listed in the interface. So the interface is just a list of stuff that if you implement that interface, you have to support that stuff. Whereas with inheritance, this functionality is fully defined. So the actual logic that represents taunting or dying or attacking is coded in here, or at least it can be. And then these guys get it for free. So whereas with an interface, you have to actually, every single thing that implements IDamageable has to define its own definition of what taking damage or dying means. So I guess the big question is, when is a good time to use an interface and when is a good time to use inheritance. So I have a couple ideas. One is you want to use an interface when naming doesn't make sense with inheritance. So a good example would be if you think about like a shooter game where the player can shoot bad guys, can also shoot crates, break them apart. There could be ammo in there. And maybe the player can also pick up that crate and throw it or move it or push it or something like that. So they do share, all these elements share a little bit of functionality, right? They all need HP. If I can destroy the crate, that means it has some sort of HP. If I can destroy the crate, it means it also supports this die functionality. But with inheritance, every child class can be said to be one of its parent classes. So a soldier is an enemy. That makes sense. A sniper is an enemy. A crate isn't really an enemy. It's different. It's a crate. It can't move. It can't attack. So it doesn't really make sense in its name, and it also doesn't make sense with all of this functionality, right? It only needs some of this stuff, not all of it, and we wouldn't really want to call a crate an enemy. So that's a couple reasons. Another big reason is that with inheritance, you can only inherit from a single parent class. So in other words, if sniper inherits from enemy, that's it. That's the only one it can inherit from, right? However, you are allowed to implement multiple interfaces. So when you have a bunch of common functionality, so in this case damageable, I can think of like there'll be many things in my game that are damageable. Some of them might be enemies, some of them might be walls, some of them, who knows, it could be a wide variety of things. Vehicles, who knows. So it might be a good idea to make that damageable an interface instead of locking all that functionality into this domain of enemy. That way, things that aren't enemies can also use those interfaces. You can see here with my crate example, I could also imagine a wide variety of things in my game the player could pick up. So I might create an pick-upable interface, and this way my crate can actually implement both interfaces. So in this example, because enemy actually implements damageable, and these are children or derived classes from enemy, the sniper and the soldier, they all get everything that's in enemy, so they can attack and move to position. They also get everything that's in damageable, so they have HP, take damage, and die. Now, the crate, on the other hand, it has damageable and it has pick-upable stuff, but it doesn't need attack or move to position. So there's just different ways to organize your stuff. I think the one thing also that's confusing about interfaces is just the name interface, right? So you can think of it, I guess, I think what's confusing for me is that I always think of the interface in terms of the player, right? What's the player going to be interacting with? How does the player use my game? So if you think of like the interface for your computer is the keyboard and the mouse, right? The interface for your Xbox is a gamepad. Well, it's weird to think about the user in the case of interfaces in code. And the way that you need to start thinking about it is the user for these interfaces are other developers, right? So this is the way other programmers can do stuff with the enemy class. We know it has this damageable interface, which means other programmers can use these things to control what enemy's doing, right? So this is literally the public interface of enemy. Under the hood, enemy can do all kinds of things that help it understand or act out what it means to be an enemy. But us as programmers, when we're trying to use the enemy in our game, these are kind of the commands we have at our disposal. So that's sort of the way I would explain why it's called an interface. It's all about imagining the target audience for that interface correctly, and the target audience is actually other programmers. All right. So to bring this all back into focus within the context of our project here, I suggest we create an interface for interactive elements. So I'm going to go inside of my scripts folder. I'm going to right click. I'm going to create a folder called interfaces. Now, honestly, I think you could make a good argument that you could set this up with a inheritance scheme, but I want us to just sort of practice interfaces. And I guess one example would be I could make this parent class interactive object, we'll say. But what if I want to have NPCs that are like other people in my game, and I want the player to be able to interact with them? It's weird to call them objects, I think. And that's maybe that's an iffy reason, but that's what I'm going to go with for now. So anyhow, we're going to open up the interfaces directory. We're going to right click, hit create, new C# script, because interfaces are still C# scripts. And I'm going to call this one I interactive. Now remember, there's certain naming conventions for interfaces. Two things. First of all, they need to start with the letter I, and then the next letter is also capitalized, so it's capital I and then capital whatever the thing is. The other idea is that you want to name it in a way that's describing what things that use this interface can do. So it's normally like an adjective phrase. So I damage a bowl, I pick up a bowl, I collect a bowl. A lot of times it's going to be with the suffix able at the end. So I could have called this I interactable, but that's actually not really a word. So I went for I interactive, which just means it's an interface for interactive things. It could be characters, it could be crates, it could be, light switches, who knows. It's pretty generic. All right, so this thing is actually, it's not a class, so we don't want to call it a class. We're going to call it an interface, and it's not, so, this right here is how we show what interfaces or parent classes a class is going to use, and our interface is not inheriting from mono behavior or anything like that. So it's just a public interface, I interactive. And I'm not even sure if really we'll need these here, but we'll see what happens. You can see how they're kind of like dimmed out. That means they're really not necessary. If we really wanted to, we could delete them, and then if we actually needed them, Visual Studio will tell us. So whatever, let's go for it. We'll just delete it, and then if we wind up needing something, we can add it back in. Now I do want us to keep up our habit of adding summaries for all of our methods and classes, and in this case interfaces. So I'm going to hit 3 forward slashes to get that hotkey in there, and you can see we have our summary tag all set up. I'm just going to call this an interface for elements the player can interact with by pressing the interact button, which we'll have to set up soon. Alright, so if you implement this interface, that means the player can walk up to you and press the interact button, and you have to do a thing. That's the guaranteed functionality that you are promising when you implement. That's just that's the way you describe using an interface. A class will implement an interface. All right, so what are the things that all I interactives need to be able to do? Well, they need to have one function at this point, and that function is going to be called interact with. So every I interactive will support a function called interact with. So it's going to be void. It won't have any return type. It's just void. And it's going to be called interact with. And the way interfaces work, remember, we're simply listing the things that all iInteractives have to support. So you're not actually defining what interact with does. You wait and do that in the class that uses this interface. Also note that you don't put any access modifiers here, like you would never say private or public, because the whole point of an interface is defining a public interface, right? So it's just assumed this is all public. If I tried to put private, it's a compile error. If I try to put public, it's a compile error because it's understood that they're all public, period. All right, let me just make sure I got my tabs correct. Okay, let's save that guy, and that's it. That's all there is to this interface. So really the next step here is to create another class that actually uses this iInteractive interface. And so I'm going to go back to my scripts directory. I'm going to right click. I'm going to create a class, or a C# script. I'm going to call it interactive object. This will just be a generic interactive object. We can probably make it reusable and all sorts of good stuff, but we'll get to that. For now, just open it up in your text editor by double clicking, and I'm just gonna again just kind of get rid of all the stuff that's stubbed in there. One thing that's cool I noticed in 2018.3, they have changed the way that at least the default script template now has the curly brackets on new lines instead of on the same line. That's pretty cool. I'm down with that. That's a nice surprise. Anyway, we want to say that our interactive object, so it's still going to, its parent is mono behavior. So every script you make in Unity that you want to ever be able to put on a game object has to have mono behavior as its parent class, which is sort of another reason why interfaces are useful, because remember, you can only have one parent, right, in C#. So we can use mono behavior as our parent, and then comma, and we can talk about, now we're wondering what kind of interfaces does this thing use. So it's going to use iInteractive, and you can see it's telling us we have an error, and it's because we're claiming that this implements the iInteractive interface. However, it doesn't implement the one thing that all iInteractives are guaranteed to have, this interact with function. So we could go and put that in there right now, but what I think is cool is if you actually click on this red underlined iInteractive and hit Control period, which is just the hotkey for like the quote-unquote quick fixes, there's actually a choice here that says Implement Interface. So you can click that or hit Enter, and then boom, it stubs in the stuff that every iInteractive needs, which in this case is just a public void interact with function. And now it's no longer underlined in red. So let's save that. All right, but you can see the sort of default that Visual Studio gave us here is this system throw new system dot not implemented exception. So if we actually tried to call interact with, it's just going to throw an exception. Well, let's give it some sort of really simple functionality just to start with. So when you interact with an object, an interactive object right now, let's just say, let's have it just print out to the console the name of the object. So let's say debug.log. Well, let's use our fancy string interpolation feature, right? So the $sign outside of your string, and that allows you to insert variables just directly in the string. So we will say player just interacted with, and then we'll type the name of the thing. So we will put in our curly brackets and just say game object with a lowercase g, which is just a reference to the game object that this script is on, and then dot, oops, I didn't mean to replace that, dot name. and we can even add some punctuation, and we need a semicolon. And so now whenever the player interacts with this thing, it should say player just interacted with whatever the name of the thing is. All right, so that's our super simple interactive object. Suppose we should go over to Unity and put the interactive object on a thing. I'm in 2D mode. I got to get out of that. So this cube was going to be our sort of default placeholder test interactive object. So let's select the cube. I guess I can even rename it. It's just to keep things organized. So we'll rename it and say interactive object, and let's add the interactive object script to it. Alright, so it's got the script, but here's the deal. We know we're looking at something. That's what this detect looked at interactive. If we recall this script from the last video, it's raycasting out and it's deciding if the raycast bumped anything. We need to be more specific and say, well, is that thing that you bumped actually an eye interactive? So that's the neat thing. We can check and see if the thing that you bumped uses the eye interactive interface. And if it does, what do we know for sure it can do? We know for sure then we can call interact with it. So that's pretty cool. So let's go back and add that sort of logic in here. So I'm going to go ahead and comment this one out. And maybe we'll delete it for good eventually here. Alright, so how do we decide if the thing that we touched with our raycast was an eye interactive? Again, there's probably several ways you could do it, but here's kind of an easy, straightforward way I'm going to do it. I'm going to make a variable of the type eye interactive. So we'll just call it eye interactive, and is the type, and the name of this will just be interactive. So this is a local variable, right? And just to be clear, we can say that it's null. And if we touch something, we're going to try and see if the thing we touched has an eye interactive component on it. So we're going to remember that we're only going to go inside of this if statement if the ray actually hit a thing, right? So what we can actually do is we can say interactive equals hit info, which was this thing that's keeping track of what our raycast hit. We know it's got data in it because we would never even go into this if statement unless we hit something, right? So that means hit info is loaded up with information about what we hit. And so we'll say hit info dot collider again dot game object dot get component. So we're going to search. So the hit info knows about the collider that we touched, and the collider knows about the game object that the collider is on. And once we have a reference to that game object, we can call get component. And we can search that game object to see if it has a component of the type eye interactive, which means is there any class that uses the eye interactive interface on that game object that we just looked at. And so we have to open close parentheses, semicolon. And now, if there actually is an eye interactive, something that uses the eye interactive interface on the game object that we looked at, we will store it in this variable we made. However, if this actually doesn't find anything, it will just fill it up with null again. So it'll just still remain null. You have to be careful because since there's a chance this might be null, we have to be careful about what we try to do with it. Like we wouldn't be able to call we can't call interact with if it's null, because then it's a null reference exception. So at this point what we want to do is say if interactive is not equal to null, which means it actually found an eye interactive in this thing, at that point we're safe to call interactive.interact with. So if we actually found an interactive there, we can try to interact with it, right? So let's go ahead and save this and test it. I'm going to hit the save all here. Go back to Unity. Wait for it to compile. There we go. And I'll run the game. And at this point, I guess as soon as I look at the thing, if it's an iInteractive, it should say whatever we typed in there. Player just interacted with interactive object. So it worked. Yeah, so anyway, if you want to see if it's continuing to work, we can look at the console. And, ooh, that's this rigid body script we might need to adjust it one day. I'm not sure if I'm crazy about this shakiness. Anyway, if I look at the thing, you can see it'll just continuously print to the console. If I stop looking at it, it stops doing it. Alright, anyway, so let's go ahead and stop the game. So here's the deal. At this point, whenever we look, every frame we're projecting the ray. If the ray bumps something, we see if it has an iInteractive on it. If it did have an iInteractive, we just immediately call interact with on that thing, which means whatever the player looks at, they're immediately interacting with. But that's not the game design I want. Let's go refer to our GDD over here and remember what's supposed to happen here. You walk near the interactive object, all right, check. You look at it, okay, check. And then number 3, you press the interact button. So this is the missing step here. We want to check, not only are you looking at the thing, but did you press the button? So that's the next step, I think. Alright, but before we get carried away and start adding in our check to see if the player pressed the interact button and then calling interact with, I think we should take a minute and reflect on what we actually named this class. Detect looked at interactive. So this class detects interactive objects the player is looking at. Remember our component pattern, right? Let's find the notes here. Component pattern, remember all this? We want to make a different component that will take care of the player checking to see if the player actually presses the interact button and then actually interacting with the thing. So let's make a new class. I will go ahead and go to my scripts folder. I'm going to right click, create C# script, and let's call this one interact with looked at. And I could say interact with looked at interactive. I guess I just feel like that's kind of redundant. So even though I'm not thrilled about this name, I suppose I'll choose it anyway. So we have one script that's going to detect looked at interactive, and a next script will interact with the looked at. So we will put this one on our player. In fact, I could even rename this player if I really wanted. Anyway, let's go ahead and throw this here. And let's double click it. You can double click that spot too to open it up in the script editor. Okay, and so what I want this to do, we can kill start for the time being, but I'm going to keep update because I want to check every frame to see if the player is pressing. I want to check two things. One, is the player currently looking at an interactive? And two, did they press the interact button? So we will say if we can just start with that interact button thing. Well, why don't we just add before we get carried away, let's go ahead and add our summary so we remember exactly what this thing's supposed to do. And once we sort of write down the definition of what it's supposed to do, we can always, it'll help us sort of steer the ship. So detects when the player presses the interact button while looking at an iInteractive, and then calls that iInteractive's interact with method. That's exactly what we want this thing to do. Two problems. One, we don't have an interact button defined. And two, we don't know, this class right here doesn't know when the player's looking at an iInteractive. This one does. So we have to define the interact button, and then we have to figure out how to have these two classes communicate with one another. So let's start by defining that interact button. So I'll just save this for now. Let's go to Unity. And remember, we want to use the Unity input manager. So let's see, they kind of move stuff around. Let's see if I can find it. So nowadays, the input manager, you go to Edit, Project Settings. It lives in the project settings. And then you can choose Input here. And you've probably seen this before, hopefully, but what we want to do is add a new one. We want to add a new input for the interact button. So we'll change the size of this list to 19, which will duplicate the last one, which was cancel. We're going to rename it. It's no longer going to be called cancel. It's going to be called interact. And now we have to decide what buttons constitute the interact button. I'm going to say that it's the left mouse button, which I think is mouse 0. And if you get it wrong, it'll just erase what you typed in. So if it stays in there, you know you did it right. If you don't know the right code, like if I try to type like left mouse, it'll just erase it. And so if you're having trouble remembering what's what or learning what's what, you just Google it. Alright, the Alt positive button, I'm going to say, I think some people find it natural to press the E button in, computer FPS games to interact with the world. So we'll have left click as well as E, both our bases covered. And then later, one day, if I wanted to add gamepad support, I could just duplicate this and add a separate positive button input definition and make that like the A button or whatever the heck I would like that button to be. Alright, so let's just double check the rest of this. It is in fact a key or mouse button, and that's basically the main thing we need to make sure is set. So now we have an interact button defined. Let's test it out. So first of all, file, save project. That's how we save our project settings as far as I'm aware. Close that. We will go to our code, and let's just, inside of update, remember we want to do input checks in update because we want the game to feel as responsive as possible, as opposed to putting it in fixed update, which would be a little slower. We don't care about saving performance, because if our game is just not responsive, it doesn't matter if it has a good frame rate. So we'll make the game responsive, and then we can optimize frame rate by calling physics stuff in the fixed update. So we'll say if input.get button. Remember, so to use the input manager, you use the get button suite of methods. If you want to hard code stuff, you use get key, and we don't want to do that. We want to use the input manager. This actually relates to another one of these programming patterns, which would be the command pattern. So maybe one day we'll talk about it, but I don't want to spend that time just this minute. But understand that the input manager is actually pretty much the command pattern, just implemented in Unity. Same thing that Unity has implemented many of those patterns. You see the component pattern, the input manager is the command pattern, and there are many more. Update is a pattern, actually, of all things. Alright, so input.get button, now we have to type in the name of the interact command, get it, and it's interact. And so if you press the interact button, what do we want to do? So for right now, let's just test that it's working, just to make sure. So we'll just say player pressed the interact button. All right, let's see how that's doing. Oops, you have to say debug.log. There we go. So we will save. Control Shift S saves all, just in case you want to use the hotkey. And so now if I left click or press E, it should print that. So, you know, we have not added the thing that checks if we're actually looking at an iInteractive yet. Look, I hit the button, it popped up down there. If we look at the console, you can see it happens every time I press the button. So just to show you again, clicked. Ooh, it went fast. So let's see. That's actually an indication that I did something wrong. The fact that it spit out so many things when I just clicked once, I think that means we are using the wrong function here. See, this says it returns true while the player is holding the button down. I don't want that. I don't want it to be like oh, you know, like, I don't want it to be like fully automatic. I want it to be semi-automatic. So I want it to be get button down, and that way it will only return true the very first frame the player presses the button down. And that way, if you hold it, it's still only going to activate the thing once. I don't want any rapid fire interactions just yet in my game. Okay, so we've basically solved this part of the problem. When they press interact button, check. Now we need to figure out if they're also looking at an iInteractive. Well, this script knows. How do we let this script know? This is one of those things where there's a million ways to do it. I'm going to show you one way and then switch to a different way. Okay, so the easiest way to do it would be to well, we need to do a little refactoring here, right? So this class basically knows when we have an interactive right here. We don't want to call interact with anymore. That's going to be the domain of the other class that the interact with looked at class. This one just needs to say, are we looking at a thing? Yes or no. And so we need a spot to store that data first of all. So let's make a let's just make a private field. Field is just a fancy name for a variable that is at the top of your class. So all of the functions in here know about it. Private iInteractive. Let's call it looked at interactive. So this is the interactive that we're currently looking at. I guess this past tense is maybe confusing. I guess I could call it the currently looked at interactive, but I'm going to just stick with this for the time being. But if that confuses you, make it more clear. That's the goal. Alright, so we have this variable. We need to supply it with a value right here. So we'll say if interactive is not equal to null, looked at interactive equals interactive. Quick refresher, we do the raycast. If the raycast hits something, we see if it has an iInteractive component. If it has an iInteractive component, we store the iInteractive object in this variable looked at interactive, which is right there. Okay, so now we need to simply have this class know how to find this function or this variable. So the direct way to do that is we could just make this thing public, right? And then other classes can access it. The catch is that outside classes, sure, they can see this, but the outside classes actually need to have a reference to an instance of this. So I guess we better figure that out. We could, pass it some way, but I think the easiest way to give this class a reference to this class would be to make a serialized field in the editor plug it in the editor. So I would say serialized field. I'm making a slot for something of the type detect looked at interactive, and we'll just give it a name. We can just call it detect looked at interactive in lowercase, like that. This should be private also, because we only want to make things public if we really need them to be. In this case we don't. So there we go. So before we forget, let's just save this. Let's head back to the editor and plug that reference in. So if we check it out, the interact with looked at script now has a slot to plug in, a detect looked at interactive. So we can just drag this one in. So we have to specify which one do we care about. This is the actual one that we care about. Okay, so now that we've made that connection, this variable has a reference to the one of these that's hooked up to the player. So we could say if input dot get button down interact and detect looked at interactive dot, what do we call it, looked at interactive is not equal to null, right? We have to make sure that this thing isn't null, which means there is in fact something that the player is currently looking at that has an iInteractive on it. So if that's the case, then right here we can interact with the thing. So we can say detect looked at interactive dot looked at interactive dot interact with. So we're interacting with the currently looked at object. Okay, so I think this will work, but it's not going to be our long-term solution. Let's just quickly test it. Just waiting for that guy to compile. Now let's see. So if I click, it says player just interacted with an interactive object. Well, that's cool. Is that what I wanted to have happen? I don't even remember. Let's see. So the interact with of this says, yeah, that's what it's supposed to do. So just remember, this cube, it has the interactive object script on it. The interactive object script implements the iInteractive interface, and inside of its interact with function, it just logs that, which if we look, this is exactly what we see here. The player just interacted with whatever the name of this thing was. I could change its name and it would say something different. Alright, so I mentioned this is not going to be our long-term solution. We can talk a little bit about why, and then figure out what the long-term solution ought to be. So if we go back and just one more time take a look at the good old component pattern, you can see actually it's even listed in this whole section called decoupling patterns, right? And so the idea is to avoid coupling together multiple classes, right? We want each class to be its own isolated little thing. And when you interconnect stuff so directly like we did right there, where we have this interact with looked at has a direct reference to this guy, right? So that's pretty much coupling. And another thing I would point out, if we check out our style conventions, we have a couple golden rules, and eventually there's a thing about this. Alright, make everything private unless necessary. So we've kind of done bad on that rule also, because we had to make this public. So yeah, this works, but it's just setting up coupling. It's inviting all kinds of stuff to look at this when maybe we don't want them to or don't need them to. So we can use a couple other techniques to refactor this code in a way that's less coupled and still accomplish the same functionality. So that's what we're going to do here. So actually, we'll do this in two phases. So if we go back and look at the notes, I'm sorry, we look at the code and style conventions document here. One of the rules, it says make everything private unless necessary, right? And then it says use properties for public variables. Alright, so here's a public variable, or we could call it a public field, and our style guide is actually telling us we should be using a property. Well, what's a property? You can check it out. Here's the whole Microsoft documentation, but again, I think a good way to learn about this is to check out the Unity tutorial video about properties. So if you've never heard of a property, I recommend you pause, click on this link, and get a quick, I mean, this thing is probably just a couple minutes long, idea about what a property is. Alright, so my personal experience is that properties are tough to understand why you should ever care about them or how they can be useful, but it's one of those things, if you just initially just go with it, before long, by the time we're done with this semester, I imagine you'll start to have an idea about like, oh wait a minute, I could actually use a property here and it will be useful to me. So just go with it for now, and I imagine you'll start to understand why it's good by the time we're done with the class. Let's hope, at least. So properties essentially encapsulate a field. So what we'll do is we'll start by making, actually, you know, there's probably like a fancy Visual Studio thing where we can just press some buttons like a hotkey and actually encapsulate this thing into a property like that. So I just hit Control period and you can see it can automatically do it for me. But I'm not going to do that because we should probably talk about it a little bit. So step one, let's make this private. So as soon as I make this private, all of a sudden this guy isn't going to be compiling anymore because it can't access that anymore. So we'll have to fix that soon. Instead of directly accessing this, that other class is going to access a property that encapsulates this variable. So this property is allowed to be public. It's still going to be of the type iInteractive, and it's basically going to be the same name as this except capitalized. So Pascal case instead of camel case. So we'll call it looked at interactive. Oops. So that is basically a property, but we need to define what this property is. So we will use curly brackets, right? So a property is almost like a super variable. It's like a variable that contains two methods. One for whatever happens when you access or try to read the variable, and another for whatever happens when someone tries to change the value of the variable. And so those are called the get accessor and then the set. So these are like two little functions that get called whenever you try to read or write to this special variable that's called a property. And so the easiest way to implement this is to say, basically, remember we're encapsulating this guy. So whenever you try to read the value of this, we are just going to return looked at interactive, just like that. So this is all that this little method is going to do, is return the value of this variable, right? And then when you try to change the value of this, the sort of most basic way to deal with it would just say that the encapsulated variable here, this one, equals value, which is just a keyword that represents whatever is being passed in when you try to change the value of this. So we can use this property just like a variable. So just to demonstrate, if I were to go stub in a start method again, I could say something like this: looked at interactive equals, well, it has to set it equal to an iInteractive. So how about this? Let's kill this function and let's put it down here where there's a good old iInteractive right there. I could say looked at interactive equals interactive, just like that. And so when I do that, when I try to set the value of this property, it's going to go into the set and then do whatever the logic is inside of it, which in this case is just change the value of this variable to the value I'm passing in, right? So at this point it's like, well, why in the world would you ever go through all this rigmarole instead of just using a regular variable? Well, here's one reason. The whole point of this class, I don't know what's going on here, let's close that. Anyway, the whole point of the detect looked at interactive class is to figure out what interactive the player is looking at, right? That's the point of this class. So the point of the class is to figure out the value of this. That's the whole point. Why would I let outside classes set the value of this? That's the whole point of this class, is to figure out the value of this. Other classes don't know what I'm actually looking at. Only this class does. So all other classes can do is screw this up, right? So I may find myself in a situation where I need this other outside class, like this one. This one needs to know the value of this property, right? So at this point I can just sub this out and use the capitalized one, which is the property, and it'll compile again. So this one needs to know the value of that. But none of them need to be able to set the value of it. So there's a couple ways we can accomplish that. We could either say, we can say private set, which means only this class is allowed to set the value of it. So to demonstrate, if I were to go over here and try to say detect looked at interactive dot looked at interactive equals something, it just won't work. It says the set accessor is inaccessible because it's private, right? So that's one way to protect that from getting messed up by outside classes. Whereas if I just used a public variable, you don't have that layer of control. Another way to sort of accomplish this, if I wanted to make this variable just totally read-only, I could just not even include a set, right? And at that point I could just directly change the value of the actual variable with the lowercase l. But I'm not going to do that because we might actually, I'm confident I'm going to want to use this set accessor for more stuff soon. So anyway, at a minimum, the property lets us control, it lets us separate read and write access. So outside classes at this point are allowed to read the value of this, but they cannot set the value of it. Only this class can. Alright, so that's one case for properties, but we'll use it further very soon. Okay, so let's just save everything and double check that our new property setup actually works. And if it does, I think this might be a decent stopping point for this video. So I click it and it still printed out and worked. So that's cool. All right, so at this point, we've got it so you can interact with the iInteractives, and we addressed this problem I had, which was we never want to use public variables. We want to use properties, right? But we still have the issue of the coupling, right? This class, detect looked at interactive, is still very coupled with this one because of this reference right here. So in the next video, we will look at a strategy for decoupling these two classes and still keeping the same functionality. But for right now, we're calling it a day.